Hi guys, so another question from section 4.5 is number 49. So we have, this one actually is a definite integral. So this one is going to be a number because remember when you have limits of integration, this is what we call definite integral. The last two videos I did a few minutes ago, those were of course indefinite integral. But anyway, so we have integral from 0 to 2 of e to the 4x dx. Okay, so the difference here between when you do have limits of integration, these numbers, and the one that you don't, of course, is because the ones that you don't have the limit, those are called indefinite integrals, and these are called definite integrals. And the main difference is at the end, whenever you have these numbers, you're going to get a number as a result of this integral. Of course, when you don't have these numbers, if you go back to our last two videos, the answer was always a function. It wasn't a number, okay? But anyway, so how do we do it? So there is this, in this section, you learn about the fundamental theorem of calculus that basically says that you just have to find the antiderivative. Of course, we know the antiderivative of e to the 4x. Remember the formula? Integral of e to the ax. Of course, this is without the limits of integration. Dx was, of course, 1 over a e to the ax plus c, okay? So remember this formula from a couple of sections back. So, of course, your a is 4 in this case because you have e to the 4x, which means you're going to have 1/4 times e to the 4x, or just e to the 4x over 4, okay? So that's your antiderivative. So fundamental theorem of calculus says once you find the antiderivative, which in this case is going to be 1/4, because your a is again 4 in this case, times e to the 4x, and then we're going to evaluate that. Remember, this vertical line means from the lower limit, which is 0, to the upper limit, which is 2. So this is basically what the fundamental theorem of calculus says, right? So once you find, in other words, if you ignore the limits of integration, you just find that antiderivative, which comes from the formula here we had before. And then, of course, once you find that, now you're going to take this function, which is the answer to your indefinite integral. And then you're going to plug in the upper. Always remember, you plug in the upper limit first, upper number, and then minus, you plug in the lower number. So this is going to be 1/4 times e to the 4 times x, because remember, your x is 2, times 2, and then minus 1/4 e to the 4 times the lower limit, which of course that x is 0, okay, 4 times 0. So now, of course, this is going to be 4 times 2 is 8, so that's 1/4 times e to the 8. Now, 4 times 0 is 0, as you know anything to 0 is 1, so that's just going to be 1/4 times 1, which is 1/4, okay? So there's your answer. Sometimes they factor that common factor, in this case 1/4, so you can also write that as, if you factor the 1/4 out, of course, from the first term, you just left with e to the 8. And as you factor 1/4 from 1/4, of course, leaves you with the 1, okay? So that you can also leave your answer like that, okay? Oh, I forgot my... by the way, in this case, you don't have a plus c. Remember, plus c is only when you have no limits, but when you do have a limit, once you find the antiderivative, just drop the c and then take that and evaluate from top to the bottom, which means you plug in the top number in place of all your x's, and then minus, you plug in the lower limit, the bottom number, and then, of course, you evaluate, and that number, by the way, the answer usually are left with the e. Of course, you know, I'm sure you can evaluate that in your calculator. Remember the e to the x button. But most of the time, everybody leave the answer with the e because everybody knows what e represents, okay? So most likely, the exact answer should be this one. All right.